So even though we won't be able to have our computer on the AP exam, I thought it was important to show you this binomial option on your computer so we could use this when going through problems. So this is Geogebra / classic and then the pound symbol and the word probability. Okay, I'll put the link into the class pages and I'll put this in Unit 4. When you open up this item, it actually is set on the normal model. And this would be useful for any of the normal problem. Obviously, again, we can only use our calculator on the AP exam, but this is a nice app to screen capture a picture from. You can use this option over here to export the picture, and you can do greater than, you can do in between, and you could do less than pictures in a nice, easier cumulative density function here. Okay, so it's just an aside on normal model. It also provides your mean and standard deviation here, and your probabilities as well. Okay, but we can use the same option for a lot of the other curves that are available. The one that we're focused on right now is the binomial. Okay, so remember, binomial requires a set number of trials. So a recent problem we did was a family was looking at blood types and they had 5 children. So we can set the sample size there at 5. What they were looking for is the probability that their child had a blood type of O, and there was a 25% chance of that. So you could set your P at 0.25, as long as we can assume that each child will have an independent chance at having type O blood, and that probability is consistent along the way. You only have 2 options here. It's either they have it or they don't. So it's a binary situation. A set number of trials, independence, and a consistent probability of success. This is a binomial distribution. Okay. The nice thing about this app is it shows you all of the different individual outcomes on the side here. So your value of x here, and then the corresponding probability of each. And then we have a binomial histogram that shows the whole distribution all at once rather than looking at individual probabilities on your calculator. Okay, so this is a very helpful tool. You can see here that the distribution is skewed to the right, so it's more likely to have 1 or 2 children that have the type O blood than to have all 5, and you can see that there. And the individual probabilities here. If you wanted to look at this as a cumulative distribution, which we don't use a lot, but it is something that comes up, we can click on this and look at it that way, just like an ogive. Usually we want to look at it this way. And then the nice thing again about this applet is we can use this to find the between, the greater than, or the less than. Okay, so most of the time when we're looking at our problems, we have these inequality symbols to deal with. If we're just looking for an individual probability, these are over here. So exactly 0 or exactly 1 or exactly 2, those are those numbers there. If we were looking for a cumulative probability over a certain range, that's where this comes into play. Okay, so if you look at the wording of a problem, you want to see if it says more than or between or no more than, exactly, less than, at least, at most, things like that will tell you which one of these to look at. So let's say, for example, they wanted to know the probability that there were no more than 3 children that had the type O blood. Okay, so no more than would be less than or equal to 3. Okay, so you would change this number to 3, and this purple region here would represent the combination of 0, 1, 2, or 3. Right? Rather than calculating all of these individual ones independently, it adds those all up. Okay, if you wanted to find the probability that it was between 3 and 4, you would just switch to this middle one and then adjust these numbers for the compound inequality. And again, you can see the probability that's representing that, so a little bit more than 10%, and you can see the area represented in the curve. Okay, and then if it's at least 3, you can adjust it in that way too, looking at the right-hand side of the distribution. Okay, so this graph is just, and this setup is just a little bit nicer than our graphing calculator. I wish we could use this on the AP exam, but for now we can use it to kind of work through problems, check our answers, and understand a little bit more about how these binomial distributions work. Okay, so hopefully this was a helpful tool, and you're welcome to use it. I'll put the link in both the class pages and the course content for this topic. Okay, thanks for watching.